In this lesson, we're going to take a look at average speed and velocity, displacement, distance. We're going to put these things together. We have a basic understanding that speed describes how fast. Speed is how fast. Now, what we do there is we actually compare a distance to a change in time. So we really have speed is an equation which says this is equal to distance traveled divided by elapsed time. So however long it took us to get that distance, that's the time that we use. Now, speed is a scalar quantity. It does not include a direction. It's always positive, and it's a scalar. Okay? However, in physics, we also need to know about direction. It's not good enough to just know how fast something's moving. We also need to know which direction it's moving. And so we introduced the concept of velocity. Now, if we're going to include a directed distance, now we're talking about displacement. And so velocity is similar, except that this is equal to displacement over time. Right? It's still the amount of time it takes in order to get that displacement. Now, are these two things the same? We've got to be careful, by the way. I should really be putting average velocity and average speed. Are these the same? No. Is the magnitude of velocity the magnitude of speed? No. So let's take a look at what's going on. If I have my reference point, we'll call this 0 meters, and we're only going to be moving on the positive x direction. Say something moves 70 meters, and then it travels back another 30 meters, so it ends up at 40 meters. So we had this direction, this direction, this direction. Okay, well, how far did we go? Well, our distance is equal to 70 plus 30, which equals 100 meters. Now, how much time did it take? I don't know. Let's say that time 0, when this whole thing started, was equal to 0 seconds. And when this thing ended, this t is equal to 100 seconds. Then our elapsed time, which we can call delta t, by the way. Elapsed time, this is delta t. Remember, delta means change in, and displacement's change in position, so I have delta x. This would be delta d, change in distance, over delta t. Our elapsed time over here, delta t, equals 100 seconds. And so if I want to get my average speed would be my 100 meters divided by 100 seconds, which equals 1 meter per second. So I had an average speed of 1 meter per second. And you'll notice none of my distances are negative because it doesn't make sense to talk about negative distance. It's a scalar. It doesn't have a negative. However, if I want to get my average velocity, I need my delta x. And remember, delta x is equal to change in position, which is my final position minus my initial position, x minus x naught, where that is my position at the end of the elapsed time minus my position at time 0 at the beginning of the elapsed time. Well, my final position is 40 meters. My initial position is 0 meters. 40 minus 0 equals 40 meters. And the elapsed time is still 100 seconds, which means if I find my average velocity, and if I write v with a bar over it, that's average velocity. So average velocity is delta x over delta t. What I have is 40 over 100, which equals 0.4 meters per second. You'll notice that that's different than 1 meter per second because we have this displacement. Basically, I could have achieved the same final position by just moving this way at 0.4 meters per second as opposed to going all the way here and back again at 1 meter per second. So my average velocity is displacement over time. Now, it's important to note that this is average, and we'll see why later. This happened to be a positive velocity, so that does indicate that I'm moving to the right. Had I had a negative velocity, all that would mean is that my position was going to the left, and so I would be getting motion to the left as opposed to the right.